I can float.
Hello everyone, today we are going to learn how to name the organic molecules. So see, these are so many different organic molecules. Today we will learn how to name it. Okay, and these are all the questions given to one of my students from Nigeria. Okay, so let's start and let's help him out, and let's all of us learn a little bit of nomenclature about organic compounds. Okay, so let me start with the video and then I will be teaching you how you will do it in details. First we will be doing today only with examples. Okay, so we will be learning today the nomenclature of organic compounds. Okay, how you will find the naming. Okay, now, so first, when you go for organic molecule, first you have to, if you want to name it, okay, first you will see the parent chain. Okay, so you will first see what is the parent chain. So the largest chain in the molecule is called the parent chain. Okay, so the parent chain will be the largest largest in the molecule. So you have to count from where it is the largest. So there will be substitution also, but you have to check first is the parent chain. Second comes your functional groups. Okay, functional groups, how many functional groups are present, through which you will name it differently. Then you have your, you can say how many halogens are there in a molecules. Okay, is it a cyclo, okay, or aromatic? These things you have to first check. So I'll be teaching you with an example how to check. Okay, and then further details of nomenclature will be giving you in another video. Okay, so let's start with the first molecule. Now let's see, this is the first molecule we have. Now see, you have to count. How you will count here is that, see, these are nothing but all carbon atoms. Okay, so 1 2 3 4 carbon, and 1 2 3. So this way if you go, it is only 3. So this is not the largest chain, so this will not be our parent molecule. The parent molecule will be this longest chain, so it will be 1 2 3 1 2 3 and 4. And why we are counting from 1 2 3 and 4, and why not from here? Because the functional group is nearer to the the substitution is nearer to the number. You have to give preference to the substitution. So here, since there is a methyl substituent here, so this we will start with naming from this side, because this is side the substituted molecule is very much near to it. Okay, so 1 2 3 and 4. So it will be, what will be 4 means it's butane. Okay, so okay, if it, because it's, there is no double bond, no triple bond, it is only a simple alkyl chain, so it will be butane, first thing of homologous series. So it will be your 2-methyl butane, 2-methyl butane. Okay, where the methyl is substituted in the second position, so it is, your name will be, IUPAC name is 2-methyl butane. Now check out this second molecule. Now see, here we will count the largest chain, 1 2 3 4 5 6 7 8. This is the one. Okay, or you can say 1 2 3 4 5. So this is the shortest chain, hence this will not be the parent chain. So our namings will start from, the largest chain is this chain, so we will be doing from this side. Why we will count from this side? Because the substitution is nearer, so we will give preference to the substitution one. So 1 2, third carbon, these are all 4 carbon, 5th 6 7 8. So it is in the third one, it is ethyl, because 1 2 ethyl, so it is in third one 3 ethyl. Okay, 3 ethyl octane. Okay, now if I just put one substitution here, see, suppose if this is the molecule. Okay, now check. Now here it is a ethyl group and here it is a methyl group. The functional group here has changed. Okay, so now what we are going to do, we will be from which side you will be put the counting. You will put the counting from this side, the bigger chain, 1 2 3 4 5 6 7 8. Why? Because the methyl, from between the ethyl and methyl, we give preference to methyl group first. Okay, methyl is the smallest one, so we give preference to methyl. So these preference and everything I'll be teaching you in some other videos, but just if you know some little bit, then you just remember this. Okay, so 1 2 3 4 5 6 7 8. Why? Because here we are just doing the examples. Okay, so here it will be, now the name will be 3-methyl. Okay, 3-methyl 6-ethyl octane. Okay, 3-methyl 6-ethyl octane. Now see, this is the third molecule. What we will do here is that, because see, whenever the cyclic thing comes, okay, and the normal alkyl chain, we give preference to cyclic one. Okay, so we will be, and because here substitution is ethyl and methyl, because this is the ethyl one and this methyl, will we start counting from here. Okay, 1 2 3 4 5 and 6. So it's cyclohexane because it is 6. So hexane, and it is cyclo, so it will be 1-methyl 3-ethyl cyclohexane. 1-methyl 6-ethyl cyclohexane. Okay, so now these number 4 and number 5 we will do. See this molecule here, it is C. This is a functional group. This is ether group. Okay, ether, when we make it ether groups, when we explain and we say it is oxy. Okay, so it is 1 2 3. Okay, so it is, and this is a methyl substituent, so we will say it is 3-methoxy because it is 3. So parent chain is 3, so it will be 3-methoxypropane because it is ester group, so it is oxy. Okay, propane. So these things will be doing in details. Okay, but for this point, because we are doing only with examples, so we will be only doing this. So now see here, this is an ethene molecule. Okay, so it is 1 and 2. We can do 1 and 2, 2 carbon are there, and these are all substituted. So, whenever you will understand there is like this, no, there is drawing, that means there is a carbon, CH3 group. Okay, now these are all CH3 group. These are not H, these are not hydrogen. If there is hydrogen, they will be giving you hydrogen. If there is nothing, like there is no hydrogen, hence there is only CH3 groups. So it is like there is 2 CH3 group, so 1 comma 1 we will write 2. Okay, dimethyl ethene because it is double bonded, so ENE group. Okay, so this is your name. Okay, let's do this one. Okay, now what happens, let's do this. We're doing this one now. See here, this also cyclo one. Okay, and we will count nearer to this double bond, because here we will give preference to double bond. Okay, that because our substitution here is the there is a CH3 group. Okay, and there is another you can say there is double bond, so we give preference to double bond. So hence we'll start counting from here. 1 2 3 4 1 2 3. So 1 2 3 4 5. Why? Because why 1 2 3? Because here the substitution should be nearer. Okay, we will have, first we will give preference to this one, but second preference should come here. So hence we will go this way. We are not going this way, because if you count from this side, 1 2 3 4, it comes in the 4th position, whereas when the methyl comes in the 3rd position if we go for this side. So it will be your what will be your thing? This is your 3-methyl cyclopentane pent 1 ene. Okay, because in the first position there is double bond. Now this one, 1 2 3 4 5 6. Okay, 1 2 3 4 5 6, and similarly here we will give preference to the larger substituted saturated molecule. So this is the ethyne molecule. So now hexine. Okay, so it will be 5th. In 5th position there is a substitution, so 5-methyl hex, because it is 6 carbon, 2, because in the 2nd position there is triple bond, so 2 YENE. Number 7, check here, it is like 1 2 3 4 5 6. 1 2 3 4 5 6. It is 6 carbon chain, and 2nd position we have triple bond, and the 5th position we have double bond. So 5-ethynyl. Okay, 5-ethynyl hex 2 in. Okay, hex 2 wine, because there is 2nd position there is a triple bond. Okay, this is your answer. Now let's go for this molecule. What is this? See here, there is chlorine and bromine. Okay, there is chlorine and bromine. Now when during in halogens, what we do, as we go down the group, we give preference to the bigger halogen first. Okay, so we will give a preference here. So our carbon chain will count from this side, 1 2 3 4 and 5. Okay, we will give preference to this. So we will, because, and bromine also, because the word B comes from before chlorine, before C, B comes before C, so we say that we take this one bromine as we give preference to bromine first. So now the answer will be 1 bromo, 3,3, because there is 2 substitution of chlorine atom in the third carbon, 3,3 dichloro, okay, pentane. Okay, hydroxy 1, because this is the 2 is the both same functional group. Okay, so the preference will be given to both. So it will be prop 1,3 diol. Okay, now we will go for this molecule. Now see, this is a molecule where you have a ketone group, there is a carboxylic acid group, and there is an alcohol group. So what we will, and we should know that we give preference to more to carboxylic group. Okay, then we give preference to your ketone group, and then we give preference to your alcohol. Okay, so this is actually the thing. So this will, I will be giving in a details one, but here I'm just solving the example. So first we will give preference to carboxylic group. Now, so we will start from here, 1 2 3 and 4 and 5. So this, your parent chain is consists of 5. So it is, so this will be your your functional group will be this one. So this comes in the last, so it will be, we will write like this. Okay, so we will give 2 hydroxy, 2 hydroxy. Okay, so 2 hydroxy, pent 4 ONE 1 OIC acid. Okay, so this you will not write like this, we will be changing it to, so how we will write the name. Okay, we will write the name as, see, this is our molecule, is it not? Okay, and there is what I said is that, see, it will be whenever you should remember, whenever there is a ketone group, okay, and according to that you have a carboxylic acid group also. So when here it is I and O and E of these two molecules will go away, we will not count, we will just remove this, and then we will write oic acid, ONIC acid. Okay, so this our name will be, now it will be 2 hydroxy pent 4 oinic acid, 4 pentanoic acid. Okay, pent 4 oic acid, because in the, it is in the 4th position, so we have to give 1 2 3 4 and 5. Okay, now done. Now these two molecules, what we will do now, see here, this is a benzene ring. Okay, but there is a substitution of bromine and chlorine, so we get first to bromine and then to chlorine, 1 2. Okay, so 1 2 3 4 5 and 6. So 1 bromo, 2 chloro, benzene. Okay, and this one is your, here also we will give preference to carboxylic acid first, 1 2 3 4 5 6, and we will write, start with the functional group. Here it is this one, and this is your parent molecule only, so it will be 4 hydroxy benzenoic acid. This molecule. Okay, so here the functional group is a ketone and a methyl group, so we'll give preference to ketone first. Okay, we'll start from here, so we'll count 1 2 3 4 and 5. Okay, so here we will give preference to this ketone group, and so we will write this 4 methyl, so it is 5, hence it will be pent. Okay, 2 because in the second position there is a ketone group, so ONE, pent 2 1. Okay, so let's see if there is any other molecule out here. So it is the same one. See, this is an ester group, ether group, so let's see, this will be, this is the methyl, okay, and this is 1 2 1 3, so you can say methoxy propane. Okay, so now this one, check this molecule. Okay, here also you have okay, one ketone group, aldehyde group. Okay, the aldehyde group, so this will start with the given preference to the aldehyde 1 2 3 and 4, so it will be 3 bromo, because why always we write halogen as before. Okay, remember that. So it's 3 bromo. Okay, 3 bromo, so it is 1 2 3 4, so it is bute. Okay, butanal. Why butanal? Because it is one position only, so one position we do not need to write, so it is butanal. So it is 3 bromo butanal. Okay, so with this these examples, I'm ending this video out here. Okay, and if you want some more example, I'll be showing you. If you want detailed more explanation of how to give preference to which functional group and which halogen and everything, why we are giving preference and how to name, I'll be going into details in the other video, but this was because it was on demand of one student, so I made it, and I hope you all will learn from this also. Okay, and all the best, and you can share among your friends also if you want, so that they will learn. Okay, thank you so much.